The Himalayas. They're not just the world's most impressive mountains, but also a natural water tower for most of Asia. More than 10 great rivers are born here, including the Indus, the Ganges, and the Brahmaputra. A fifth of the world's population depends on these rivers for their drinking water, their agriculture, their industry, and their sanitation. And now, as the global climate changes, slowly but surely, all these could be in jeopardy. Rising temperatures, melting glaciers, changing monsoon patterns, all will heavily affect 1 billion or so people throughout Asia. Meanwhile, the water cycle in this remote area remains a mystery. We know little about patterns of snowfall. We don't fully understand the role played by glaciers. And it's high time we start learning. When moist air collides with mountains, rain and snow are the result. Nothing new there. But now, scientists need to unravel how this interplay actually works in detail. Although there's not much scientific data, there are many theories. So it's time to put them to the test.
We understand the basics of the Himalayan water cycle. The water in the rivers comes from monsoon, from snowmelt and glacier melt, but it's the specifics that are the challenge. We really need to understand how glacier change in the future will affect the river flows in the future as well.
Even if there's no rain, then glacial melt fills the rivers. And presently the Himalayas are losing ice at a rate of about 9,000 sports stadiums full of ice every year. But glacial melt is not the only component. We also have snow melt and we have monsoon rains, and they also fill the rivers. So to really understand how the system is working, we need to know how this varies in time and space, all of those components.
To adapt to climate change, we need to understand per season which component is most important and how this varies throughout the region. And so an international group of scientists from Utrecht University, from ETH Zurich, and from the International Center for Integrated Mountain Development in Kathmandu has teamed up to investigate high-altitude precipitation in the Langtang catchment of Nepal. For several years now, this team has performed systematic experiments and taken measurements before and after the monsoon seasons. And the results are, to say the least, illuminating.
This is the third pluviometer we have set up in the framework of the DFID-funded program. This pluviometer is at 4,475 meters. We have another one which is at almost the same elevation, which we have set up a few days ago. And then there is a third one which is at 4,900 meters. This provides us a unique data set of high altitude precipitation, which I think in the entire Himalayas is very unique. And we are going to use these data both on the rainfall and the snowfall to improve the hydrological modeling of these kinds of catchments.
And what has been discovered provides significant new insights into the hydrology of the world's premier mountain range. First, the differences in precipitation measured at the various stations were much greater than expected. And second, the actual amount of snow and rain measured at high altitudes far exceeded all previous estimates. Snow feeds the glaciers, where rising temperatures have a devastating effect. Like here, on the Lirung Glacier, that turns out to be in pretty bad shape.
The Lirung Glacier is a debris-covered glacier of about 3.5 kilometers long, and it's very hard to do fieldwork on such glaciers. And now with the advent of new technology that we are using here, we are able to cover extensive areas, and we can map it, and we can also derive very detailed elevation models.
The repeated measurements in 2013 show that the glacier has come to a virtual standstill in the last few years.
160 meters. Now it's coming back.
The formation of surface lakes accelerates melting processes. More and more sports stadiums full of water are simply vanishing. And the fate of the Lirung could prove symptomatic for what is happening throughout this vast range.
You also see that
The data gathered by the unmanned airborne vehicles permit scientists to fine-tune their simulation models in a much higher resolution than ever before. The result? more accuracy and better predictions.
We have been using remote sensing observation for a long time now to study the hydrology of the Himalayas. But technology developments around unmanned airborne vehicles and the software to process these images has advanced so much that we can now study the dynamics of the glaciers in unprecedented detail. So these remote sensing developments will have a major impact on glaciology studies in the region.
The good news is that the Himalayas are not going to run out of water just yet. They will continue to supply Asia for many years to come. The bad news is that there are serious challenges ahead when it comes to dealing with climatic extremes. The mountains are not nearly as resilient as they once were, and so there are dangers.
It's likely that we're going to see more extreme events, more floods and droughts from a changing monsoon pattern. Not only that, we lose some resilience when we lose the glaciers. We lose a bit of natural water storage that, for example, could help us with dry season flows. So what in the future is still uncertain. People have to adapt to a range of possibilities, and we still have to figure out how to adjust to those possibilities.
As always, improved understanding can lead to better policy decisions. And so, it is of vital importance that this comprehensive approach to monitoring precipitation and glacier development continues, expanding both its scope and precision over the years to come. The more we know about how these watersheds work, the better we will be able to adapt to a changing and increasingly unpredictable water supply.
Well, during the last few years we've come a long way, and we have focused mostly on modeling and satellite remote sensing. But to really understand what's happening on the ground, we need to use the technology like the UAVs and the high-altitude precipitation instruments to understand the impacts of climate change. We've shown now that this is very well possible in one catchment in Nepal, but the variation throughout the Himalayas is so large that we really have to extend this technology throughout the entire region.
As is so often the case in science, there is really one thing missing from the equation, and that is secure, long-term funding. Research costs money, it's that simple. But in the case of the Himalayas, continued ignorance is simply not an option, because that too could come at a high price for people and for ecosystems.